In this lecture, we will start with the Cartesian plane, and the next following lectures will all be based on it. In the 16th century, mathematicians René Descartes and Peter Fermat invented a powerful method of representing equations geometrically, and this is what is known as the Cartesian plane in honor of Descartes. The Cartesian plane consists of a horizontal axis, called the x-axis, and a vertical axis, called the y-axis. Points in the plane are determined by their movement first along the x-axis and then along the y-axis. Positive numbers designate movement in the right and up directions, and negative numbers designate movement in the left and down directions. A point in this plane is described by a pair of numbers, x, y, where the first coordinate x is the designation of the point on the horizontal axis, and where the second coordinate y is the designation of the point on the vertical axis. Here are some examples of points written out in the coordinates in the Cartesian plane. -2, -4, -1, 1, -2, 2, 0, 2, 1, 3, 2, 0, all of these being based on their x and y values. The red points have coordinates written next to them. The first coordinate is the position on the point on the horizontal axis, and the second coordinate is the position of the point on the vertical axis. These points are represented by a pair, x, y, next to them. Whenever we have two distinct points, we can draw a line or line segment between them. For example, say we have one point, 2, 3, and another point, 5, 7. We can draw this red dotted line segment between them. How steep is this line? How can we assign a number that measures how steep is this line? Consider this as a thought experiment. If you walk 2 feet forward and raise up by 9 feet, let's say on a hill in New York City, then let's say on another hill in Florida, you walk 3 feet forward and raise up by 10 feet. Where is it steeper? On which hill? In the New York City hill, you rise 9 feet for every 2 feet that you move forward. So the steepness is 9 divided by 2. In the Florida hill, you rose 10 feet for every 3 feet. So the steepness is 10 divided by 3. Since 9 divided by 2 is greater than 10 divided by 3, the steepness of the New York City hill is bigger. The idea behind measuring steepness is to divide rise by run. The rise is how much you get elevated, and the run is how much you walk across. Let's return to our 2 points and the line segment between them. How steep is this line? The rise is the length of the vertical green line. It is 4 units long. And the length is the run of the horizontal green line. It's 3 units long. So the steepness of this line is 4 divided by 3. In general, to get the run, we subtract the x-coordinates of the 2 points. And to get the rise, we subtract the y-coordinates of the 2 points. Note in our example above, the 2 points are 2, 3, and 5, 7. The run is the horizontal distance, and since we start at 2 and move to 5, we travel 5 minus 2, or 3 units. The rise is the vertical distance, and since we start at 2 and move to 7, we travel 7 minus 3, or 4 units. In general, we don't even need to draw a picture for the location of the points, though it may be helpful. We can just subtract the corresponding coordinates to get the answer. In math, instead of using the word steepness, we use the word slope. In our example above, the slope of the line is 4 divided by 3, or 4/3, or 1 1/3. Another piece of notation is that the standard is to use the letter m to represent the slope of the line. The general formula goes as follows. Suppose x1 and y1 is the coordinate of the first point, and x2, y2 is the coordinate of the second point. The slope of the line segment between the 2 points is the formula, m, which is the slope, equals y2 minus y1 divided by x2 minus x1, or the difference between the y's divided by the difference between the x's. Let's take an example. Find the slope of the line between points 1, 2 and 5, 9. In the formula above, we have a first point and a second point. You may wonder which one is the first one and which one is the second one. The answer is it doesn't matter. As long as you're consistent about it, you can do it either way. Imagine drawing a line either from 1, 2 to 5, 9, or from 5, 9 to 1, 2. The way which you draw the line doesn't matter, it's still the same line, and the slope will be the same regardless. But it's important to pick one point to be the starting point and one point to be the ending point, and to be consistent about it. Let's say that x1, y1 is 1, 2, and the ending point, or x2, y2, is 5, 9. So the slope is given by m equals y2 minus y1 divided by x2 minus x1, which is 9 minus 2 divided by 4 minus 1, or 7 divided by 3. So the slope is 7/3, or 2 1/3. Note, it's important to know which coordinate is x1 and x2, and which coordinate is y1 and y2. If we do it randomly, we may get a different and wrong answer, so be sure to pay attention to the order in which you call your points. Let's take another example. Find the slope of the line between 0, 1 and 1, 0. Let's say that x1, y1 is 0, 1, and x2, y2 is 1, 0. The order in which we call the first and second point is not important. What's important is that after we pick an order, that we stick to that order in applying the slope formula. The slope is given by m equals y2 minus y1 divided by x2 minus x1, like above, which equals 0 minus 1 divided by 1 minus 0, or negative 1 divided by 1 equals negative 1. What does it mean that the slope m is negative? Negative slope is really descent instead of steepness. It goes down instead of up. If you plot these points in the Cartesian plane and draw the line segment, you will notice that the line is going down when looking at it from left to right. So the line is descending rather than ascending, as it did in the other examples. Positive slope means the line segment is ascending when looking at it from left to right, and negative slope means the line segment is descending. What about a zero slope? If m equals 0, it means the line segment is flat. It is neither ascending nor descending. It is a flat, horizontal line. For example, suppose that x1, y1 is 6, 2, and x2, y2 is 10, 2. We get the slope by m equals 2 minus 2 divided by 10 minus 6, which is 0 divided by 4, which of course is 0. The slope is 0. This is not a surprise because the 2 points, when they're graphed, will notice that the line segment connecting them is horizontally flat, so it has no steepness at all, and thus a 0 slope. If a line is directly vertical, the denominator, or the change in x, will end up being 0, which is an imaginary number, and that's what's sometimes referred to as no slope instead of 0 slope, because the formula gets you an undefined number with a denominator of 0. In the next lecture, we'll start working with lines. Lines can be described by equations in Cartesian planes. In fact, as we'll see, various kinds of equations produce different types of curves. And this is a link between algebra and geometry. It allows us to think algebraically of geometry and geometrically of algebra.